Okay, so for my discussion 3 post, I decided to collect data regarding my summer job. So, in the summer, I teach dance classes as one of my primary jobs, and I have a lot of friends that also teach dance classes as their primary jobs. So, I decided to take a data set based off of the amount of classes that each one of these 5 people teach in a week. So this is only 1 week of data. And so Ben teaches one contemporary class a week and one technique class a week, so he only teaches 2 classes total for that week. And I went through the most common styles that everyone teaches, and I tallied up the numbers. So these are all of the classes that each person individually teaches per week, and then this would be the total classes in a week that all 5 people teach. So this is the first data set that I started with to first and foremost create my histogram. So then I come over here, and so the first thing I did was I made a frequency table, and I decided that my histogram was going to be a visual image describing the amount of classes that each person could teach in a week, since the numbers were varied on a broad scale. So the first thing I did was make bins. So I made bins of 4, so 0 through 4, 5 to 8, and 9 to 12. So they each pick off where each left off, and then I turned that bin size into a frequency. So 2 people taught between 0 and 4 classes, which would give me a percentage of 40% of the 5 people. From 5 to 8 classes a week, that was only 1 person, so 20%, and for 9 to 12 classes, 2 people, also 40%, totaling up to 100%. This is then shown here in our graph, where the bottom x-axis is total number of classes and the y-axis is frequency, and what it's showing is our bin sizes, 0 to 4, 5 to 8, and 9 through 12, and it's giving us all of that information. If I wanted to change the bin sizes to make them smaller or larger, depending on what the visual I was trying to give, I could really just go into my frequency table and change the range. So I would change this, I could change this to, let's say, 3.0, and then it would edit that to 0 to 3, but I'm not going to do that because I like it in 4. But that is how I would go about that process, and it's super easy and to change. And then I just changed the colors, and I added a border to this histogram so it was clearly defined the amount. And it looks big, even though it's not that big of a pool of people, but I thought it was very visually representative of the data. So that is what I did for my histogram. And so now moving on into my scatter plot. So the first thing I did was once again, I made another data table. And so for our histogram, I only used 1 week of data. This is the same data that we used for week 1. And these are the ID numbers of our participants. And then for week 2, I did the same thing. Each person, and I took the amount of classes that each person taught during week 2. So number 1, who I pretty sure was Ben, taught 2 classes in week 1 and 3 classes in week 2. And so we just totaled up. So 33 classes were taught week 1 and 35 classes were taught week 2. So the first thing I did was I took the mean of all of these. So I put in the average, C2 to C6, to get the means of both of these. So these are our means. And then from there, I took the standard deviation using the stdev.p for all of these numbers, because Excel is so awesome and does all the math for you. So then using those numbers, I was able to calculate the correlation coefficient of 0.77. So I did that by using the awesome correlation Corel formula, and then using all of the data points B2 to B6 to get how we got our average, and then C2 to C6. So we used that data, plugged and chugged, and we got 0.7, which is a pretty strong correlation coefficient, considering that one is the best you can have. So it really describes the strength of the linear association pretty well. So then after that, what was really necessary to do was to calculate do a linear regression of this to figure out some type of trend line. So in reality, you would, if we were doing it by hand, I would find the slope. So I took the slope. As we know, we can find slope y equals mx plus b and intercept by doing classic math. So we did this by doing this formula, and then I found the intercept by performing this formula, and then I could hook that into this to get the equation. But the much simpler way that I did it was I inserted a trend line, and then from there I took the trend line and I inserted the equation that came with that. So to get the trend line, all I did was click on that, click on chart design, go to add chart element, trend line, more trend line options, and so I wanted a linear trend line and I wanted it to display the equation on the chart. And so another really cool thing to do is if you happen to know the Excel formulas and are able to do this and get these numbers, I was able to double check this work, because I did this first, by using this formula that it gave me to insert this trend line. So why is this linear regression line appropriate? Well, as you can see, we see this kind of nice trend here, and then we have a dip here, and then a nice high point there. So between the 2 weeks, there isn't too much deviation. It's not very high numbers on our y-intercept, nothing too crazy, but as you can see, it does take into account this person that taught 9 classes in the first week and only 4 in the second week, and takes into account someone who taught high classes both weeks as opposed to other people. But other than that, it is a pretty appropriate regression line, and I think it displays the data very well. So thanks so much for listening.